Okay, what else you got?
Looking through this.
Look for your ones that are quotients. Those are going to be the ones that are going to be 0 over 0.
Okay, so this one, well, this one doesn't have 0 over 0, but it has 0 in the denominator.
Okay, well, let's look at least one of those so you know what those are.
So x plus 5, and then in parentheses squared, minus 25 over x as x approaches 0.
Well, notice that we do have 0 over 0. Right?
Yeah.
Okay. So, we've got to somehow change this thing so that when we substitute x equals 0, we don't have 0 over 0. And an obvious thing that I can do is distribute this, multiply this out. What do you have? What's x plus 5 squared?
Okay, so you have x squared plus 10x plus 25.
Now what can you do?
You can, so we'll cancel out those 25s and pull out an x.
And then factor out an x. And now because you were able to factor out an x, you can cancel that x with that one. And what happens to this thing as x goes to 0?
It becomes 10.
That's how you do limits when you end up with 0 over 0. Is you want to somehow factor that denominator out. Okay, what else you got? Now, let's just talk about that for a moment. Let's say I had 2 over x. What's the limit of that as x goes to 0?
I don't know.
It's infinity. Or undefined. In other words, if you have a fixed numerator, as the denominator gets smaller and smaller and smaller, this whole thing gets bigger and bigger and bigger. I mean, try it. Try 2 over 0.1, and then try 2 over 0.01, and then try 2 over 0.000001. Your answer just keeps getting bigger and bigger and bigger. Okay? So that's why those aren't problems. And if I have the reverse, if I have x over 2, what's the limit of that as x goes to 0?
1, 0. Dang.
In other words, if your numerator is 0, 0 over 2 is 0. So if your numerator is going to 0 or if your denominator is going to 0, you know what the answer is going to be. The only thing that's indeterminate is when we have 0 over 0. Like that. Okay? And with this, I've got 0 over 0, but I can cancel an x out, so I end up with this, which becomes 1 over 0, which becomes infinity.
Okay.
All right. What other problems do you have?
Okay. So this one's kind of weird. Can we do one that requires graphing?
Sure.
Okay. So this one wants you to find the limit of 1 over 5 plus x.
Over 5 what?
Plus x minus 1/5 over x as x approaches 0.
Did I write it correctly?
All of it over x. So, including the first, yeah.
Like this?
Uh-huh.
Okay. So,
And then it wants to solve
so
it.
if we do a direct substitution, what are we looking at?
A weird quotient thingy where
It's 0 over 0. In other words, all of the hard ones are always going to be 0 over 0. If it's not 0 over 0, it's very easy. You'll get used to that. The only ones that are tough are 0 over 0. So how can I solve this? What can I do at that top? The numerator. How would you subtract those two fractions?
Well, don't you find the, what's it called, the least common denominator?
Yes. What's the least common denominator? Here's my big fraction bar. And then I'm going to have that fraction bar, that fraction bar. What's going to be the least common denominator of the numerator?
5 parentheses 5 plus x.
Correct. What goes here and here? What goes on the left?
Sorry, what did you say?
What goes in the first circle?
Oh, 5.
Okay. What goes in the second on the right?
5 plus x.
Do I need to put that in parentheses?
No.
Okay. Tell me what I now have. Hold on. Let me make this a little smaller just so we can tell what we're doing here.
You multiply the bottom as well?
Well, let's see. The bottom has a common denominator. The question is, what is its top? What is 5
x?
minus that?
X, wouldn't it be?
It's negative x. That's why I ask about the parentheses. You need the parentheses there. In other words, if I use parentheses, now when I simplify the top, I get 5 minus x. So you get a minus x right there. So this is a particular type of algebra where you have to introduce parentheses that weren't there originally. If you don't introduce those parentheses, you get the sign wrong on the second term. Okay, so now reduce that. That's what we're looking at. How do I do that? How do you divide by fractions?
Don't you flip it?
That's how we're going to do this. Is I'm going to pretend there's a 1 under it, and now flip and multiply. So we have minus x over 5 times 5 plus x. That's our numerator. And our new denominator becomes this. Now solve that.
Okay.
Multiply
so
numerators.
Yeah, so you get negative x over 5x times 5x.
Basically, the x's cancel like that, and you end up with negative 1 in the numerator, and this in the denominator. Right? You can see that, right?
Yeah.
Okay, now take the limit of that as x goes to 0.
So it would be negative 1 over 10? Negative 1 over 25.
Negative 1 over 25. In other words, it's the same on all of these limit problems. when you start off with 0 over 0, if you can somehow algebraically manipulate it and get rid of the 0 in the denominator, which is what we did, notice the x canceled, and we were left with minus 1 over this, which is no longer 0. In other words, when I plug in 0 for x now, I got minus 1/25, and that's our limit. Okay? So you went up through limits, but no further. You didn't do first derivatives?
No.
Okay. What other limit problems would you like to look at? Or any of your stuff. Your review packet must be pretty broad in scope, I would think.
Yeah, it is. It's quite substantial.
Yeah, I run into this every year, where people come down and they end up with 1 hour of tutoring and they got 5 hours of material to cover.
Yeah.
Right before the finals. So, like I said, if you need any extra time, I can put you in some.
All right, awesome. All right, so these are just more like limit problems.
Okay.
So this one is, and then brackets, 2x minus 3 over the absolute value of x minus 2 as x approaches negative infinity.
All right. I guess there's one other problem besides 0 over 0. There's things called indeterminates. Okay? 0 over 0 is indeterminate. I don't know what that's going to be. That could be 0, that could be infinity, that could be 17, it could be minus 1,000,000. All right? Another indeterminate is infinity over infinity. Another indeterminate is 0 times infinity. We don't know what any of these are. Okay? In other words, they're going to require more manipulation when we end up with a problem like this. Well, this problem, as x goes to negative infinity, the numerator goes to negative infinity, and the denominator goes to negative infinity. So this is an indeterminate. But we know what the limit's going to be based on the fact that the numerator has a maximum exponent of 1 on a variable. The denominator has a maximum exponent of 1. Therefore, let's take away these absolute value signs for a second. What's the limit of that as x goes to infinity? Remember that x going to infinity is the right-hand end behavior, right?
Yeah.
So it's going to go to the horizontal asymptote. Where's the horizontal asymptote on this thing?
Horizontal, okay, wait. Vertical asymptotes and horizontal asymptotes. Horizontal asymptotes are the fractions, so 2?
Yes. In other words, if I was going to graph this function, there's a vertical asymptote at x equal 2, because that's what makes the denominator 0. But there's a horizontal asymptote at y equal 2 also. Hold on. And it's hyperbolic in nature, meaning it's probably going to look something like this. And as x goes to positive infinity, this function goes to 2. As x goes to negative infinity, this function goes to 2. Okay?
Okay.
So let's look piece by piece. Now let's let it go to negative infinity. What would the function go to if we were going to negative infinity?
Also 2.
Now let's put in our absolute value sign. And notice that the moment I put the absolute value in there, Let's see. What's the consequence of that? As the bottom goes to negative infinity, it's actually going to positive infinity, right?
Yeah.
The top is still going to negative infinity. So we end up with a negative infinity divided by positive infinity. What do you suppose that's going to? That's not indeterminate. Wow, I'm not sure I know what this is. I immediately assumed it was 0. Because the bottom blows up and the top gets more and more negative. Nah, this thing must go to negative 1? Wow. Do you have answers on this one?
Should. Maybe. No, I don't think she gave us answers to the graph. Oh, yeah, she did.
I'm positive what this goes to. I'm going to guess negative 1 or 0.
The answer she gave us for this one is, I don't know, actually. She gave us, negative 1 over 25.
Did it? For this problem, that was the last problem. We just did that last problem.
No. Oh, yeah. Sorry. 8. Negative 2
Negative 2.
is the limit.
Okay. Now I get that now. Because what we really have is negative 2 infinity over infinity. And that's going to be negative 2. Yeah. That's a difficult limit problem for somebody that's just been introduced to limits. Yeah. I'm not even sure why, if I can explain that or not. In other words, if I didn't have the absolute value sign there, we know it goes to positive 2 because the ratio of those coefficients is positive. Well, when I put the absolute value sign in there and I let x go to negative infinity, the ratio still has to be some variation of 2. The problem is that the top is going to negative infinity, the bottom is going to positive infinity, and so we basically have this situation here, but we still have a 2 in that numerator. So it's still the ratio of the coefficients, which is minus 2 over 1. So that's how you get this. This is a tricky one. Very tricky.
Yeah. I get it, though, I think. I get it.
Yeah, that's difficult to explain even.
Yeah.
We got time for maybe one more.
Okay. Find the limit of x plus 2 over 3 minus x as x approaches infinity.
So again, if we do a direct substitution, the numerator goes to infinity. The denominator goes to what?
I don't know.
Negative
infinity.
In other words, 3 minus infinity is the same as 1 minus infinity, is the same as 10 minus infinity, is the same as 1,000,000 minus infinity. It's minus infinity. The infinity always rules over any constant. So now, what's the limit of that?
Wouldn't it be like negative 1?
Yep. It's the ratio of the coefficients. All right. You going to be good to go until next Tuesday?
I think so.
Okay. I got lots of time available on Thursday, Friday, and Saturday if you need something extra.
All right, sounds good. I'll message you.
Okay. And David's going to be here tonight at 6:30?
He should be.
Okay.
I told him, so.
Okay. Sounds good. I'll talk to you next Tuesday, and I'll talk to him later tonight.
All right, sounds good.
All right, Sarah. Bye-bye.
Bye.